Okay. Yeah, there was a... Is the track tomorrow? Is there a track meet tomorrow?
Yeah.
Okay. Somebody told me about like a track meet coming up, but I'm pretty sure it was not today. I'm pretty sure it's tomorrow. But yeah. All right, I got you. Yeah, they'll send an email or something.
Okay.
I don't know, but I'm assuming will they announce something?
She said she wasn't, but she just said to try to teach that 12.
All right, I got you. Oh, that Miss Cherry, pulling kids out of class all the time. I don't know. Anyway, back to this. There he is. Okay, so first, let me give you the heads up as to the timeline. Let me give you a reminder as to what's due. And actually, no, let me tell you what's due first, and then I'll tell you about the timeline. As I said last class, I was going to be assigning something in regards to sequences and series to kind of wrap that thing up. So yesterday, I had posted a quizzes assessment that I was giving you guys 3 opportunities to get done, 3 chances to take that particular quizzes. A few of you have already taken advantage of that, which is fantastic. I'm just double checking right now because with the scores that are submitted at the moment may not be the final scores based on people taking advantage of the multiple attempts. I gave everybody 3 attempts to get that thing done. So I'm just getting into quizzes right now and just double checking. So yeah, of the people who have taken it so far, it looks like they've only used 1 attempt, but they do have 3 attempts total. That assessment, that quizzes assessment, is not due, and I'm going to turn the camera so people can see my calendar as well, but that quizzes assessment, I made it due on Wednesday the 9th because I wanted to give everybody plenty of time to use all 3 attempts. But once that 3rd attempt is done, I will, of course, take the best score and input that into Genesis. So today is Thursday the 3rd. It's the last day this week that I have you. And yes, today we will be beginning our final exam review. We will be beginning our final exam review. I will have instructions for you as to what to do about that. Next week, I have you on Monday, which is senior exams for 1A, 2A, but we will continue reviewing on Monday. We will continue reviewing on Wednesday, and then you will be taking your final exam on Friday the 11th. So again, please keep that in mind. Friday the 11th is going to be here so much sooner than you think. In terms of the final exam, like I said, I will make the Linkit code available to access said final exam on Friday the 11th. For those that are virtual, obviously you need to be here in the virtual classroom to be able to get that particular code, which will be available during the exam period. And then you'll be able to access the Linkit, knock that thing out, and we'll see where it goes from there. So please make sure you're on time for that. Friday is going to be the full class period, so you will have like an hour and 20 to get that thing done. Fantastic. But like I said, as for today, we are going to be beginning the final exam review. Just as a reminder, where is it? I'll turn the thing back here. There it is. Seniors will be excused. Seniors will be excused the last week of school from class, so I won't have to worry about seniors on the 17th, but I will be taking a regular attendance on Thursday the 17th. Please keep that in mind. I will be taking a regular attendance. So for those that are online, I will have something for you to check in attendance-wise. Okay, here's what I have for you. I am posting on the Google Classroom. I'll flip over and show you. I am posting on the Google Classroom, boom, the final exam review for this particular class. My objective over the next 3 class periods is to go over every single problem on this particular review. Now, some of these things we haven't seen for quite some time. Some of these things are a bit more recent. We'll see how it goes. This is the review that the other Algebra 2 CP classes will be using as well, or they should be using as well. I know at least one other teacher that will be using it in preparation for this online quizzes final exam. Now, I didn't print this out because it would have been a lot of paper, number one. But you do have access to it through Google Classroom. So here's what I'm going to suggest. I am about to begin going through these problems. I would suggest that if you want to see the problems and not squint at the screen, yes, by all means, have those Chromebooks out, log on so you can follow along. But the other thing that I strongly suggest is that if I'm reviewing these problems, I'm actually going to be writing out what to do for those problems. I'm going to strongly suggest that, well, I need to study for this thing. What do I have to study? What do I have to know? Perhaps maybe I should write some of this stuff down. Yes, perhaps that would be in my best interest. That was loud. But I am going to suggest that you do write some of this stuff down. So wherever you're going to write this stuff down, into your notes, on a separate sheet of paper, whatever you need to do, I'm reviewing this stuff now. The study guide is available to you through Google Classroom. You can access that anytime. It's just been posted. But I'm going to be going through it like this, and I'm going to be flipping back and forth between my live camera here, and we'll see how this thing goes. So here we go. For my purposes, I am going to be labeling my paper as final exam review. You'll see that right here in a moment once I zoom back out. There we go. Today is June 3rd. This is my final exam review. Not trying to do anything fancy. I'm literally just going to go through it, let's say a problem at a time. Some of these problems are going to take you a bit longer. Some of these problems are going to be incredibly short. We do have 3 class periods to get through whatever we need to, and I'm going to take my time going through these questions. So let me write down what we got for number 1. Number 1 gives you 2 functions, f of x and g of x. I'll be able to flip over my camera in just a moment. I'm writing down f of x and g of x very carefully. There are 3 parts to this particular question. Number 1. Part A is asking for you to find the roots of f of x. Part B is asking for you to divide the 2 functions. And part C is simply asking if g of x is a factor of f of x. There we go. Oh, before I forget, of course, I just brought up that live chat. If you have not left a comment, 1, 2, 3, 4, 5, 6, 7, 8. I see the 8 comments that are there so far. But if you have not left a comment, please make sure that you do so. Okay. So part A is asking for the roots of f of x. Let me flip my camera over. Here we go. As a reminder, especially for this final exam, when they are asking for something like roots, roots are also known as x-intercepts, also known as zeros, also known as solutions. They all mean the same thing. If they're asking for the roots of the function, they all mean the same thing, x-intercept, zeros, solutions. And they're just asking for the roots of f of x, that quadratic. So if I were to take that quadratic and wanted to find the roots, I have one of 2 options. I have one of 2 options. Option number 1, I attempt to factor it. And if I can factor it, then I can identify any of the zeros. The problem is not everything is factorable. Option 2, quadratic formula. So let me try option 1. Let me see what happens. If I attempt to factor this particular quadratic, I can't take out a greatest common factor because, well, the greatest common factor is 1, so I can't do anything there. So then if I decide to proceed with the Tucker method, a times c gives me positive 2. All right. Positive 2. I got to find myself 2 magic numbers. Oh, and then I run into a brick wall. Oh. The brick wall that I run into is that, well, what 2 numbers multiply to positive 2? It's like, what, 1 and 2? Yeah, but that doesn't add up to the b value. That doesn't add up to the middle value of -1. I can try -1 and -2, but that also still does not work. This is not possible. Factoring would have been nice. Factoring would have been clean. Factoring would have been great. But unfortunately, no such magic numbers exist. Thus, we cannot rely on factoring. We have no other choice. We have to rely on the quadratic formula. So if you happen to remember what the quadratic formula looks like or not, I'm going to write it down right here. This is that magical quadratic formula that you've been seeing for years and years and years on end. -b plus or minus the square root of b squared minus 4ac. The whole thing is over 2a. Now I'm looking at this thing and I'm like, okay, I have to plug in the appropriate pieces of information into this equation, and supposedly it will spit out my solutions. It will spit out my answers, my zeros to this particular problem. Now, it wasn't factorable, but that doesn't mean that I don't have solutions, because I do. If I plug in the appropriate information, I'm going to take my time with this. -b, notice I put that in double parentheses, the negative of the b value, plus or minus the square root of b squared minus 4 times a times c. The whole thing is over 2 times a. Now again, this is a lot of information that's being thrown at once. Let me try to simplify this thing down as best we can. It should be getting me 1 plus or minus the square root of -7. Ooh. The whole thing is over 4. Ooh. Not a huge fan of that. What the heck? That's a negative underneath a square root? Yes, yes it is. There's a lot of things a lot of things that I'm trying to remind you of all at once. Number one, the fact that they wanted roots, so we had to try and solve the quadratic. Factoring didn't work, even though, I mean, it would have been great if it did, but factoring didn't work, so we had to rely on the quadratic formula. I threw that stuff into the quadratic formula, and underneath the square root, I got a negative. What that means for us, what that means for this problem, is the fact that you're going to get an I. You are going to get an I. This negative right here, what I'm pointing to with the pen, that negative underneath the square root produces a non-real answer. Non-real answer. So I have to account for it by just doing one simple thing. This is all that I have to do, because the rest of this is not going to simplify. That negative comes out as an I because it's the square root of -1. That 7 now is positive because I ripped that negative out of the square root. But by ripping that negative out of the square root, it becomes an I. Nothing else changes. This terrible looking fraction is the answer to part A. That terrible looking fraction, unfortunately, is the answer, is the solution, is the zero, is the root of that quadratic. There's nothing else we can really do about that. Ugh. Again, terrible looking, but unfortunately, that's what we have to deal with. But then, in part B, we take it a bit farther. Let me scroll this thing up. Part B is using the exact same equations. They're using the 2x squared minus x plus 1. Oh, absolutely. Absolutely. Just to this bottom part of the whole thing?
Just the bottom.
Okay. Let me leave it right there.
I think
Oh, no worries. Let me leave it there for just a moment, though, just in case for other people. In part B, they are asking for you to take that original f of x quadratic, but this time they want you to divide it by g of x. They want you to divide them. Now, this takes us back. This takes us back to, I don't even know what month it was that we learned this. It might have been January. It's been a while since we've seen this stuff. It has been a minute since we have seen this kind of information. But in order to divide polynomials like this, I have to reintroduce you to this bar. This bar. This is the synthetic bar. The synthetic bar was how we were to divide these polynomials. Where, okay, technically it's a quadratic divided by this linear binomial. On the inside of the synthetic bar, I'm going to write the following numbers. These numbers represent the coefficients from that original quadratic. It is a 2x squared minus 1x plus 1. They are the coefficients of what the top of the fraction would be, the numerator. Now, we are dividing by x minus 4, but there is a certain number that goes right here, a certain number that goes on the outside of that synthetic bar. And what it is the, quote, 0 of x minus 4. It's not just a negative 4 that goes out there. It's not at all. It's actually going to be a positive 4 that goes on the outside of that bar. Because what they really want there is the 0 of that binomial. If you took x minus 4 and set it equal to 0 and tried to solve it, it would end up being x equals positive 4. A positive 4 is what has to go on the outside of that bar. It has to. This is how synthetic division is going to work and how it is going to help us. Now, using the bar, that's a whole other story. Using the bar, actually dividing it using this synthetic bar, is nothing more than repeated addition, multiplication. Addition, multiplication. That's all that it's going to be, is going back and forth between addition and multiplication until you eventually get to a final number. The first number, as I've shown you in the past, always just comes straight down. Nothing happens to it. It just drops straight down to the bottom. And then we multiply. We multiply these two numbers together to get positive 8. And then we add. We add vertically to get positive 7. Then we multiply, because it's going back and forth, and we multiply these two numbers. Again, you always multiply by the number on the outside when you're dividing. But you multiply and you get 28. And then you finally add these two numbers vertically, and you get 29. Now, this completes the synthetic division, but now it is up to you to interpret how these, or what these numbers actually mean. Again, nothing more. It's like 2 plus nothing, 2 times 4. Negative 1 plus 8, 7 times 4. 1 plus 28. It's always adding in a vertical direction. It's always multiplying against that positive 4. This number right here. You got to tell me, you got to remind me, what the heck is that number? Now, yes, it's a 29, but what is it? in the context of the problem. When we did synthetic division last January, we were hoping that that number would turn out to be something. We were hoping that that number would actually end up being 0. Because if it ended up being 0, then we knew we were on the right track to solving something. But no, it's not a 0, it's a 29. Ugh. That number is our remainder. That number is our remainder. When you do division, back in the day in elementary school when you did division, there will always be like some sort of a remainder. Remainder 2, remainder 0, remainder 5. Doesn't matter what it was, but you ended up with some kind of a remainder, and you had to identify it as a remainder. And eventually they taught you what to do with them. This last number is your remainder. This number represents the constant. This number represents the x term. If there were more numbers, we would keep going, and then the next one would be x squared, and the next cubed, etc. But right here, that's all we have. We have a remainder, we have a constant, we have an x term. So let me go back to the study guide and actually see what the question is asking of me. Let me see what the question is asking of me. Flip. It says to divide the 2 and identify the remainder. That's what number 1 part B is asking me to do. It's asking me to divide them and then to identify the remainder. Well, when I divided them, my answer was, and look where I'm pointing, my answer was 2x plus 7, remainder 29. There's my answer. Not only did I divide them and show what the result of that division was, but I also identified what my remainder was. That's answering part B in its entirety. Now, I'm going to flip back to the screen in a moment. I will flip back to the screen in a moment, but let me just flip to part C real quick. Part C. Is g of x a factor of f of x? Is g of x, the x minus 4, is it a factor of the quadratic? No, it's not. Well, how do you know that? Well, I know it's not because I did not get a 0 for my remainder. If I got a 0 for my remainder, that would mean that it actually divided evenly. If I got a 0 for the remainder, then that would mean that, well, yeah, it is a factor. It would actually divide this thing out. It would factor out of the polynomial. But no, I got a 29. So I would say, no, g of x is not a factor because the remainder wasn't 0. That's the simple explanation. G of x is not a factor because the remainder wasn't 0. If the remainder was 0, then yeah, it is a factor. Oh, happy day. All right, this review is going to jump around a little bit, but let's go around to number 2. Do you guys know what Carvana is? Do you know anyone who's ordered stuff from Carvana? Yeah?
You.
Besides me. Shut up. All right. It's really cool because I have never been, but apparently Carvana is like a car vending machine system. Yeah, I didn't do that. I ordered it online and they delivered it to my house. Thought it was really cool. It reminded me because of number 2. Number 2 is talking about buying a car, but it's buying a car for a cheap amount of money. It was so cool though, because like we ordered the car online. I had to because I had a 2005 Honda Civic, and the cost of repairing this car was way more than the value. Hey, do you know how much money you can get for scrapping a car?
That's $500.
Where are you going to scrap a car?
Well, my mom's old car was like really bad. They only scrapped it for like a couple of bucks.
That's what I'm saying. They're only a couple $100,
Yeah.
not 500.
Yeah.
Yeah.
It was a minivan.
Okay, but still, even still, no, I could have only scrapped it for like a couple $100. That was the deal.
Yeah.
But I found a guy who was just like, oh, I'll take the car off your hands, and I'll pay for the repairs. And I'd be like, okay, but you got to know here's all the stuff that has to be done to it. My goodness, never buy a new car, never buy a brand new car, always buy a pre-owned car. Goodness gracious. Let me write down this stuff. So the dude bought the car for $641.85. It depreciates at 23% a year. Now that's not the case for all cars. That's just the case for this car. So number 2 wants you to do 2 things. They want you to set up a model for the value of the car in 2 years, and then they want to know what will the car be worth in 20 years. Here's what I've written down so far. The model is going to utilize this equation that we have done time and time and time again. This is the exponential decay model. Did I tell you about my Toyota Prius? I told you that story. Still sad about it. Still super sad about it. Barnegat High School student. Goodness gracious. The Barnegat High School student who rear-ended me and we lost our Prius, she was a senior at the time. She was a senior in 2013, 2014, something like that. So it's been like 7 years. My goodness gracious. So that Barnegat High School student, I didn't teach her, but I saw her in the hallways like in the weeks and months after she rear-ended my car, and she could never look me in the eyes. She always like averted her face. I felt bad, but she killed my car. Anyway, the value of A represents the initial value. The value of R represents the rate, in this case, the rate of decay. And the exponent is going to represent time. Now, in this case, again, the exponent has to be measured in the same time unit as the rate. Since the rate is 23% a year, then we can represent the exponent in years. The model would be written like this. Now, yes, the guy is purchasing the car today for $641.85, and they're eventually going to want to know what the car is worth in 20 years from today. So we're treating the $641.85 as if it were the initial value. But obviously, it's not the original price of the car because that's not what they're asking for. They eventually want to know what is the value of the car after 20 years. I don't know what the heck you're going to be driving a car 20 years later unless you're really maintaining that car. Goodness. My Honda Civic, you couldn't, you know how like there's a button or like a lever to like release like the gas cap? You know what I'm talking about? It wouldn't work on the Honda. It would not work. Apparently, there was like a tubing thing that broke underneath the car, and if I was going to replace it, it'd be like $200, $300 because there was like a tubing thing that stretched the length of the bottom of the car. So what ended up happening was I said, screw it. I'm just going to open up the gas tank myself. So whenever I went to go get gas, I had to jump out, open the trunk, work my hand in through the side of the car between like the fabric and like the metal end, and I had to like fiddle something in order to pop open the gas tank every time. I did that for 2 years. It was worth it. I'm not going to spend $200, $300 fix that when I could easily just do this. Now, in this case, again, it is 1 minus 0.23. If you wanted to simplify that and make it a 0.77, you could do that if you wanted to make it a 0.77. In fact, I'm going to make it a 0.77 right here when I do the next calculation. But if you plug in a 20, because T is measured in years, then this would spit out $3.45. That's why I asked about like the scrapping of the car. There's no way that a car would be worth $3.45. You could at least get like scrap metal for it, even if it was just falling apart. Oh, cars. Goodness gracious. I've seen all these like Tesla videos. They're pretty crazy. But there are other electronic car companies coming out soon. You guys ever hear of Fisker? No? Fisker Automotives? Couple of years, you're going to hear their name. Trust me. They have this thing where it's like they have solar panels that basically make up the roof of the car and are protected on the roof of the car. So as you're driving around, you're also recharging the battery as well. It's an interesting idea. Instead of having to stop at a charging station. Regardless. Okay. Changing gears, looking at number 3. Looking at number 3. It is asking for you to find the product of those two fractions in simplest form. Okay. Let me write these down, and let's see what we can do with them. I need to be very clear about this problem. People always end up confusing how to multiply fractions and what they call the butterfly method. I do not know who taught you the butterfly method. I reminded you of the butterfly method this year, but this problem does not utilize the butterfly method. It does not. And the reason why it does not is because between the two fractions is not an equal sign. That is a multiplication symbol. And because you are multiplying these two fractions together, you are multiplying straight across. Top times top, bottom times bottom. But before we actually do that, I'm going to do one tiny little thing here. I'm going to do one little tiny thing before we actually multiply across. And I would strongly suggest that you do the same thing. I'm not going to do anything to the second fraction, but to the first fraction, I'm going to do this. I put it in red so that you can see that a little bit better. If you were to factor by taking out a greatest common factor out of the top left fraction, you would then be able to identify an x minus 2 that cancels out with the other x minus 2, which is really nice. Because once they cancel, well, all of my variables are now gone. I can multiply this thing as normal. Now, if you wanted to simplify other stuff, you could. You could simplify the 6 and the 2, but let's just ignore that temporarily, and let's multiply top times top, bottom times bottom, and then just simplify the result. The answer to that crazy thing is just a 9. It's legitimately just a 9. It's really weird. You got to make sure that you factor. If you can factor first and simplify some junk out, by all means, you absolutely can do that. Okay. Let's take a look at number 4. Number 4 is talking a little bit about probability, and it's talking about marbles. Have I told you guys about my bag of marbles? They're somewhere in the room. I legitimately had a bag of multicolored marbles that I could use for like a problem like this, but I have misplaced them somewhere in the room. They're somewhere. I legitimately don't know where they are, actually. I thought I knew. You know, I said that joke to somebody yesterday, and it legitimately took them like 2 minutes to figure it out. The joke was I lost my marbles. was hilarious. But legitimately, I don't know where the bag is. But now here's the thing. Look at number 4 real quick. Look at number 4 in the way that it's worded right here. Look at that chunk right there. Obviously, you have the PDF if need be. Let me read the problem, and then let me tell you what your reaction typically would be to a problem like number 4. You look at number 4, and you're like, one bag contains 2 green marbles, 4 white marbles. Second bag contains 3 green marbles, white marbles. I don't care. I don't want to read this. Not all people, but most people are not even going to try and read this whole thing because they don't want to. I get that. Which is why I strongly suggest, okay, reading the problem is not very helpful. But if you take it piece by piece, think about each bag individually, and actually maybe draw a representation of it, something like this might be incredibly helpful as a visualization. In the first bag, I have 2 green marbles and 4 white marbles. In the second bag, there are 3 green marbles and 1 white marble. This is the visual representation of this problem. I haven't even considered the question yet. I just needed to visually represent what the 2 bags of marbles looked like. Because sometimes it's hard to conceptualize this stuff. But now let me actually go back and read what the question is asking. The question is saying, if this guy randomly draws a marble from each bag, what is the probability that they are both green? What he's really asking for is, well, what is the probability of the first bag being green and the second bag being green? That's what this question is really saying. Green and green. I'm going to show you the absolute easiest way to get this thing done. The absolute 100% easiest way to get this problem done. There are 1, 2, 3, 4, 5, 6. There are 6 marbles in the first bag, and 2 of them are green. There are 4 marbles in the second bag, and 3 of them are green. The word "and" implies multiplication. This is literally what you have to do to get the problem done. You don't have to draw that picture, but sometimes it helps for people who can't visualize what these bags actually contain. If I were to multiply these 2 fractions together, I get 6 over 24, which reduces to 1/4. And that is perfectly acceptable. It works. It does what it is supposed to do. Wonderful. There is going to be some probability on this stuff. But the probability that they're going to throw at you is going to be somewhat straightforward. Somewhat straightforward. It's not going to be fantastic, but you'll be able to get it done. In fact, number 5, I'm going to bring up number 5 right here. Number 5 is just another bid of probability. But you have to be able to interpret this correctly. Number 5 is asking 4 different questions. Random sample of 240 people asked if they preferred an SUV or a sports car. We got it from a Carvana. We got a mid-size SUV. It's wonderful. You can actually fit stuff in the back now. It's got 3rd row seating, although it's tiny. The table shows the results. Based on the information, answer the following questions. You can easily interpret this table if you can visually kind of break it apart. First, there are 240 people who took this survey, so you can see there is a 240 in the bottom right corner. That is the grand total. Part A is asking, okay, well, what percentage of the survey takers was female? Yeah, this is one where you could just kind of glance at the table and be like, okay, well, there were, according to this table, it looks like there were 180 females, 180 out of 240. Yeah, it literally is just that. Mr. Markey, that seems too good to be true. Yes, I know. But you would be so surprised at how many people just bypass a problem like this, even though it is that straightforward. What percentage of the surveyors were female? 180 out of 240. But they want a percentage. And if they want a percentage, you better give it to them as a percentage. Always answer the way that the question is actually asking. It's like one a day, right?
It's only this one. No other classes.
It's so weird. Part B. Part B, again, is another similar question to Part A. It's very straightforward in what it's asking. What percent of the participants preferred an SUV? Well, Ms. Markey, there were 156 out of 240. Yes, it is that simple. A and B are very straightforward. C and D are a little not, but we'll talk about that. But yeah, what percent preferred an SUV? Look at the SUV column. The total was 156. 156 out of 240. The result being exactly 65%. I already did that math for you. Part C is not as straightforward. You have to read Part C and be able to understand what it's actually asking of you. What percent of boys preferred a sports car? They're asking what percent of boys preferred a sports car. The biggest mistake that people are going to make on Part C is like, okay, boys, sports cars, 39. 39 out of 240. No, it's not 39 out of 240. I'm sorry. So it's 39 out of something else. Yes, but now you're on your second guess. And since you're on your second guess, you didn't know it was wrong in the first place until I told you. It's 39 out of something. It's 39 out of 60. Because when they ask the question, what percent of the boys preferred a sports car, that means that you are only looking at the group of boys. You're only looking at the guys in this problem. There were 60 guys who participated in this problem, and of those 60 guys, 39 of them preferred a sports car. That's the calculation that needs to be done. Coincidentally, it's 65% again. When they ask such a question, they are limiting how many people you're choosing from. You're no longer choosing out of the entire group of 240. You're only choosing out of that group of 60. But now look at Part D. Of those who preferred a sports car, which in this case, now you can say that there were 84. There were 84 people who preferred a sports car. 84 people who voluntarily said, yeah, I prefer a sports car better, regardless of male or female. What percent of them were girls? That's why this last one is 45 out of 84, which is a not as nice looking as a percentage, but that is indeed the answer to this question. Now let's look at number 6. Put number 6 just right here. Now, number 6 is a little bit of a reprieve. If you get a problem like number 6 should be a gimme. Number 6 should absolutely be a gimme problem. 100%. It's asking for you to solve the following. 5x plus 6 equals 2x plus 2. This is a pre-algebra problem. This problem right here is legitimately something you would see in pre-algebra, something that you would have done in middle school math, something that you wish you had done all this entire school year instead of some of the stuff that we learned in algebra 2. This should be a gimme. But again, you'd be surprised how many people just kind of flippantly just bypass this problem. Just move the x's to one side. Move that constant of 6 over to the other side. 3x equals negative 4. X equals the fraction negative 4/3, which, according to the directions, is an improper fraction. It's an improper fraction. That's all that you would have to worry about with this particular problem. Ooh, wait a minute. Okay, there. I was just reading a message, and that is a very interesting comment that was made in the message. Okay. I'm going to bypass number 7. I am going to bypass number 7. And instead, I'm going to focus on number 8. And actually, I'm going to wrap up today with number 8. Number 7, I'm not going to worry about. Number 7 is going to be one of those problems where I would make sure that credit was given where credit was needed. I'm not going to worry about teaching number. I don't have to worry about. Instead, I'm and show you how number 8 can be done. Do said problem. We will be moving into the intervention period, or the intervention part of this class period, in which I will have a few instructions for you when we get there. But we're going to wrap up today with number 8. There are multiple ways to handle number 8. Multiple ways. Some people will look at a problem like number 8 and panic. Be like, I don't know what to do. This is ridiculous. There are some people who would look at number 8 and they would be like, okay, I think I got this. I think I know what to do. And they would spend a half hour on this problem and there'd be work written all over the place. In fact, I'm going to show you something that I don't want you to write down. Let me be very clear. What I'm about to do, don't write down. Don't. I'm going to show you the easiest way to do the problem afterwards. I'm going to do the easiest way on paper afterwards. But what I'm about to write down, you should not copy down. But I've seen people do this problem where they're just like, okay, I got this. I'm going to take 5 square root of x plus 3, and I'm going to square it, and I'm going to get this. And then if I square this, it'd be like 25x plus, if I multiply those, it's like 15 square root of x, 15 square root of x. Okay, I got that. There's another 15 square root of x here. This is like some crazy kid in like honors, like calculus or some junk like that, because I'd have to square the other side, and then I'd move some junk around, and I'd get like 30 square root of x equals negative 21x minus 9, and then I'd square both sides here, and I get like 900x. If I squared that, and I squared that, and then I'd get 441. I get like 441x. Goodness gracious, 21 and 9, 9, 18, negative 189 times 2, because I get 2 negatives there, because no, it's negative, negative, positive, 18, 16, 17, 378. You can see where this is going. This is insane. No one in their right mind would do this except some kind of like weird, crazy honors kid in calculus. Why in the world would they even bother doing something like that? But they would. And if they did it that way, they would eventually end up with the correct answer. Good for them. Good for them. Take the lazy way out. What's the lazy way? The lazy way is recognizing the fact that both of these are the same type of square root of x. They both have the same square root symbol, and they both have the same base of x. Because of that, I can do this. I can subtract 5 square root of x from both sides. get 3 equals, now hold on, 2 square root of x minus 5 square root of x. They're like terms. Get negative 3 square root of x. From here, I'm going to square both sides. 9 equals 9x. X equals 1. Yeah, that works. That works for me. That's legitimately what you would have to do to this particular problem. It absolutely stinking works. There is one small, tiny little caveat to the whole thing, though. And that tiny little caveat is the fact that the answer is actually extraneous. This is all of the mathematical work that is actually needed for this particular problem. You move the 5 square root of x over to the other side. You get the following. You square both sides. You divide by 9. There it is. I'm not going to cross it out, but if you actually plug that 1 back into the original problem, you would get 5 plus 3 equals 2, which clearly does not work. This answer is what we call extraneous because it is a false solution. It is still the solution. It is still the only solution that you actually need, but since if you try to check your answer by plugging it back in, it doesn't work, you have to label it as extraneous. That is the only caveat to this whole thing. Otherwise, the work is very straightforward. The work is very short and just boom, done, and 1,000 times done. Okay. Here's what I need you guys to do. We're going to pick up with more of this review on Monday of next week. We have 2 more days of review. We have Monday and Wednesday to finish going throughout this packet as best we can. Your job right now, you have until 12:22, and this class period will be over. There are things that you owe me. There are things that you owe me. If you have not gotten those things done, you have the opportunity to get those things done before the end of this marking period. There is a quizzes on sequences and series that you have 3 attempts on. 3 attempts on. At the very least, you could get one of those attempts today. See what you get, see what you have to study, go back and kind of research what you need to know, and then go back and do the quizzes again. You have 3 attempts. Take advantage of this class period. You have 22 plus 7, you have 29 minutes to get done, need to get done in order to prepare for the end of the year. If you have any questions in regards to that stuff, of course, you can email me. For those of you in the live stream, if you have not left a comment, I do see the 1, 2, 3, 4, 5, 6, 7, 8, 9 comments that are there so far. If you have not left a comment, please make sure that you do so. And let's take advantage of this class period. Let us get to work. Yeah, that's fine. That's not us. Oh yeah, but you got
Yeah,
swimmer.
I gotta go.
Yeah, I got you.
Have a good day, Mr.
You
Martin.
too. See ya. Okay. Don't forget the stuff that I have assigned. If you haven't left a comment in the chat, please do so. There's the bell.